let's start. Okay, so good evening guys. So we'll start with the chapter system of particles and rotational motion. Okay, okay, so let's begin the class. Okay, so the first one which we are going to see is a rigid body. So when we talk about a rigid body, a body with a definite and unchanging shape. So which means when I take a rigid body or solid body, no, the particles between them will be particles, no. So one particle and the second particle will be closely packed to each other, right? So the distance between all pairs of particles do not change. That is the intermolecular. So there won't be any change in the distance and the shape will be unchanged and will be having a definite shape. So no real body is truly rigid. A real body deforms under influence of the force. So when I try to apply force on the body, no, what happens? It will deform, right? No. So motion of a rigid body. So at any instant of a time, all particles of a body have the same velocity. So if I consider this is the object, no, so object in this I am considering one particle and the second particle. Okay, this object is going with some velocity v if I consider. What about the velocity of this particle? So this particle 1 also will be v, particle 2 also velocity will be v, right? No. Abdul Rahman, good evening. Good evening. Done? Yeah. So when we are dealing with the slides, no, try to take the notes when we are explaining. Okay. So second one, so motion of a rigid body. So combination of translation and rotational motion. So different particles have different velocities. So when we talk about this a circular object, no, so when I talk about the point where both are intersecting each other, okay, when the last point of the object and the surface touches, no, that velocity will be 0, okay, and different particle having different velocities. So if I consider center, that is this is v1, and if I consider this is v2 or v4, so every particle will be having a different velocities. Okay, this is the motion of a rigid bodies and combination of translation plus the rotational motion. Done? Yeah. So next one, a line or a fixed axis about which a body is rotating is known as axis of rotation. Okay, when we talk about a fan, no, so there will be some axis of rotation, no, the ceiling fan, right? No, and when we talk about a potter's wheel, so there will be axis of rotation, that is center will say, no, the center part, yes, no. So this particles, no, if I consider these particles, so n particles are there in the wings, so these particles will rotate around this axis of rotation, no, yes, no, when like it will take the example of axis of rotation and it starts rotating, right? No, yes. So the next one, motion of a rigid body of a rotational motion. So every particle of a body moves in a circle, that line lies in the plane of perpendicular to the axis and has its center on the axis. Okay, so when we talked about the ceiling fan, we talked about the particles, no, in the wings. So that's the same thing, every particle of a body moves in a circle that lies in the plane perpendicular to the axis and has its the center of the axis. Okay, and the second point, so here we have considered particle 1, 2, 3. Okay, so this particle 1 and 2 of a distance of r1 and r2 from the center of axis, and whereas particle 3 no lies exactly in the axis. So particle P1 describes a circle of a radius R1 with its center C1 on the fixed axis. When we talk about particle 2 also, it will be having R2 as a radius. So circle lies in a plane of perpendicular to the axis. So particle 3 on a plane, on the axis remains stationary. Why it is remain stationary? It is on the axis, no. When the particles in the axis lies on the axis, it will remain stationary to the body when it is rotating. Okay. Done? Yes. So next one is precision. So when we talk about a precision, means like sometimes the axis may not be fixed. See, we have seen this toy in the childhood. We'll take this toy and we'll rotate with the rope, some rope, and we'll start rotating. So in this case what happens? The axis might be changed. Sometimes it rotates in this manner, or sometimes it will rotate in the bent manner, yes, no. So the movement of axis of the top around the vertical is termed as precision. So the point of contact of the top with the ground is fixed. When we talk about this point, no, it will be fixed, but the axis might be changed. Okay, the movement of axis of the top around the vertical is termed as precision. Done? Can we go for the next one? Okay. So center of mass is the next topic. It is the point where the entire mass of the system is assumed to be concentrated. So for uniform mass body, center of mass exactly in the geometrical center. So simple thing, when we take a non-uniform body, okay, non-uniform body, for example, people used to rotate this pad with the finger, no? Yes, no. So like when we can able to rotate, when I able to find the center point, and if I keep the finger in the center point only, I can able to rotate it now. The same thing are used in this concept also. Right now, a uniform mass body of a center of mass exactly in the geometrical center. So when I take a triangle, this equilateral triangle, the center of mass will be at exactly center. So how can I find that center? When I take this point and when I draw the other end, okay, when I take this point to the other end and this point to the other end and this point to the other end, that common intersecting point will be there, no, that is center, no. Similarly, if I take this diagonals, the intersecting of diagonal will be center of mass for the square, right. So when I talk about a rod, so center will be exactly L by 2, right now. So for a non-uniform mass system, center of mass is near to the body which is having higher mass. So what we can understand here, for non-uniform, okay, non-uniform means the mass has been unequally distributed. So center of mass is near to the body which is having the higher mass. So when we talk about the earth and the moon, no, so earth will be having more mass than the moon. So center of mass will be near to the earth surface. I mean earth only, no? Yes. So when we talk about radius, I mean distance, no? When the distance increases, mass decreases. copy down first. Okay, can we go for the next one? So now we will consider two particles. Okay, so particle 1 and particle 2 having a mass m1, mass m2. So let the distance of the particles x1 and x2 be respectively from the origin. Okay, so center of mass of the system is at a distance x from O. Okay, so we don't know where the center of mass lying. Okay, lies no. So let me consider m1 at a distance x1 and m2 at a distance x2. So a center of mass is at x. Okay, we know that since mr is constant, m1 r1 will be equals to m2 r2. So we know, like from this, no, from center, okay, exactly center, we are considering r1 and r2. Okay, so I need to find what is r1 and what is r2. r1 is nothing but x minus x1, r2 is x2 minus x. Okay, so from this I need to find what is x, right? So how to find x now? So m1 x minus m1 x1 will be equals to m2 x2 minus m2 x. So when I take m1 x plus m2 x will be equals to m1 x1 plus m2 x2. So when I take x commonly outside, what I will get? X equals to m1 x1 plus m2 x2 by m1 plus m2. So we got the center of mass formula, that is excuse me, m1 x1 plus m2 x2 by m1 plus m2. So this is for the two particles, right now. So when we talk about three particles, the formula will be x center of mass will be equals to m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. When we talk about four particles, x center of mass will be equals to m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 by m1 plus m2 plus m3 plus m4. Right now, so when we talk about n particles, up to mn xn by m1 plus m2 plus up to mn. Right now, take down. Done. Can we go for the next one? Done, sir? See, the same thing. So for the three particles are up to n particles, m1 x1 plus m2 x2 plus mn xn by m1 plus m2 up to mn xn. So the formula is summation mi xi by summation mi. Okay. So where summation mi is the total mass, no? Yes, no? The total mass, like sum of all masses will consider, no? Total mass of the system. So can I write summation of mi as capital M, the total mass of the given system. Okay. Now, so we have talked about a single axis. When we talk about a plane, okay, so plane in the sense two axes, so x axis and y axis. So similarly, we have considered three particles over here. Okay, so the distance for in x axis is x1, x2, x3, and y axis is y1, y2, and y3. So the same formula we are going to get. So for x-axis it is m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. For y center of mass it is m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3. Okay. So when the masses are equal, so m1 equals to m2 equals to m3, what can be done here? So m can be taken commonly outside, right? So m I have taken commonly outside, x1 plus x2 plus x3 by m into 3. So m and m will be get cancelled off. So x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. So this is the formula for plane in x-axis and y-axis. So center of mass of coin coincides with the centroid of the triangle formed by the particles. Done? Okay. So now for the space in the sense x-axis, y-axis and z-axis. So center of mass C of a system of a particle given by, so for 3 particles we will consider. So for 3 particles, so for 3 particles in the sense m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. For y center of mass, this is x center of mass and this is y center of mass and this is z center of mass. So m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3. So for z also m1 z1 plus m2 z2 plus m3 z3 by m1 plus m2 plus m3. So this is for the space. Okay, and this x y z, no, so the distance in the their particular axis. Okay, done. Let them copy, sir. Okay. So center of mass in terms of position vector. Okay. So position vector in the sense, so I am taking up particles. Okay. So from the origin I am considering the
3 positions.
Yes, positions. So for m1 r1 is the position from the origin, m2 r2 is the position from the origin, m3 r3 is the position from the origin. Okay. So when I talked about these 3 particles, no, m1 m2 m3, I need to find center of mass of the position. Okay, for these 3 masses. So similar formula. Okay, m1 r1 plus m2 r2 plus m3 r3 by m1 plus m2 plus m3. So here the formula is given for n particles. Okay, so which is nothing but summation mi ri by summation mi. Okay, so when we talk about this one, no, this is for the position vectors. So similarly for x, y, z also. Okay, we have talked about the space, x center of mass, y center of mass, z center of mass. Similarly for position also, x center of mass, y center of mass and z center of mass. Okay, take a note of this. Excuse me. So hope you understood, Abdul Rahman. Okay, done. So we'll go for the next one. So center of mass for a packed particles. Okay, so treating the body as a continuous mass distribution, so then a body has n small elements, right? No, so delta m1, delta m2, delta mn up to delta mn. So which is nothing but a particle which is having a smaller mass. Yes, no, when I take a whole rigid body, mass will be like for around I will take 5 kg, but when I consider each particle, no, a mass will be different, right? No, so it's a continuous mass distribution we told. So each particle will be having some each particular masses. Okay, the coordinates of the center of mass for the ith element. So ith element in the sense the nth element we are talking. Okay, so the same thing. So x center of mass, y center of mass, and z center of mass. So summation delta mi xi by delta mi for the x center of mass, for the y center of mass instead of x it is y, for z it is instead of x it is z. Okay, so when we talk about this mass, no, I am taking commonly outside, that is total mass. Okay, and integration from x dm. So similarly for 1 by m integration y dm integration 1 by m z dm. Okay, yes. So when I talk about a vector expression, it is r is equals to 1 by m integration of r dm. Okay, so if a center of mass is the origin, so r will be 0 because this value will be 0, right? So r dm will be 0. So x dm will be equals to y dm will be equals to z dm will be equals to 0. So when the center of mass is in the origin, okay, so apart from the origin there will be a center of mass. Okay, I will give you some common examples for the center of mass of a continuous mass distribution. You can take a note of this. Done? Okay. So here is the center of mass of a thin rod. So when we talk about the center of mass of a thin rod, no, it is L by 2, right? No? Yeah. So we'll do a problem now. So find the center of mass of a 3 particles at the vertices of an equilateral triangle. The masses of the particles are given, that is 100 gram, 150 gram and 200 gram respectively. The side of the equilateral triangle is 0.5 meter. So what I should consider here? So okay, fine. So only x axis and y axis, no sir, not z axis. Okay, so x and y. So this is my triangle. Okay, and when I talk about this point, this is m1, m2 they have mentioned, yeah, m2, and this is m3, right? So what are the masses? This is 100, this is 150 gram, and this one is 200 gram. The side they have mentioned as 0.5 meter, right? 0.5, 0.5 and 0.5, right? No. So when I talk about this, if I divide this one, no, perpendicular bisector, fine. Okay, 0.25 comma 0, and this one it is 0 comma 0, right? And in this point 0.5 comma 0 I am taking as a points of x and y, x1 y1 x2 y2, yes, x3 y3. So what about this point, sir? Now I need to find this height. No, we don't know the height, we know the this and this one. So 0.5 and 0.25. So can I use Pythagoras theorem here? Yes. So I don't know this one. Let me take it this as h. So hypotenuse 0.5 whole square will be equals to h square plus 0.25 the whole square. Am I right? So can I write this one 5 by 10 the whole square equals to h square plus 25 by 100 the whole square. I need h. So h will be, sorry, h square will be equals to 25 by 100, no, 10 square. So minus 125, 25 square, 625, right? No, 625 by 10,000. Okay, cross multiply it now. So 25, 0, 0, 0 and 0, 4 zeros minus 62500 divide by how many zeros? So 1, 2, 3, 4, 5, 6, 10 power 6. Okay. Yes, no, I am cross multiplying. Sir, this one I have cross multiplied and this one I have multiplied.
Sir, minus is negative symbol is there.
Yes, this one will become as negative. So 25, 10 to 10 power. You can take LCM also, no issues. Instead of LCM, what I have done? I have cross multiplied and denominator I multiplied. Okay, no? Fine.
Yes.
Okay. So now it is h will be equals to under root of 25 into 10 power 4 minus 625 into 10 power 2 by 10 power 6. Okay. We need to find the value of h, and when we got the value of h, no, we can write this one as, so what is the value? 0.25 comma h, the value of h. Yes, no? After finding this one, what we should do?
0.25. H comma 0.25.
H comma 0.25. Okay. Okay, fine. So get the value of h now. Okay. So the thing is, after this, what I should do? Wait a minute. So after this, what I should do? X center of mass will be equals to m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. This is for the x center of mass. No, I need to find for y center of mass also. Y center of mass will be equals to m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3. Right now? Yes. So mass we know m1, m2, m3 100, 150, 200. Whereas x1, x2, x3 also we know. What is x1 here? 0. x2 is 0.25. x3 is x2 is 0.5. x3 is 0.25. It is 0.5.
Sir,
yes, no. M1, which is nothing but x1, no? Yes, no. x1 what we got? 0. x2 is 0.5. Which one, sir?
X-axis, right, sir?
Yes, sir.
So x-axis it is 0, y-axis is point.
No, sir. This is 0, 0. I am increasing the distance, no?
0, 0.5.
X, y. Yes, no? Got it? Yes? Write it. So change it. Change that one. You have taken y, 0, right? It is x, 0. Okay? Yes. It's a big calculation.
Can't we simplify it?
Yeah, we can. What do you need to simplify it? You need to find h. After finding h only you can do the problem, no?
We can simplify h square equals 25 by 100. Then we can simplify.
So you can simplify here also, sir. This is 1 times and this is 4 times. Right now. And this is how much? 125. 5 times, no? And this one, so 4. So 2, 0, 0, 0. Right now. And if I, this is 25. Again this one, it is 400. Right now? So 24 and remaining 2 zeros. Again this is 5 and this is 8 zeros. 1 and this is 1 and remaining 3, 16. Right now. So cross multiply it.
1 by 4 minus 1
Okay.
by 16.
That's it. Right now.
4 minus 1
So whatever it is, I need to find the value of h now.
by 16.
So after finding h, I can use the value here. Okay.
3 by 16.
So in this case, y1 and y2 will be 0 obviously. Only y3 will be there. So x3 comma y3 and this is x1 comma y1, x2 comma y2. Okay. So x1 will be 0 whereas x2 and x3 having a value. So I need to substitute there. y1 and y2 will be 0, y3 will be having a value. Right now?
So we don't need height.
We need height for y3. Okay. So complete this problem before coming to next class. Okay. We'll wind up the class now. Okay, no? Yeah. Okay, sir. We'll meet in the next class. Okay.